So in our project, I'll be doing about the plate. Here I'm giving uniform distributed load and we'll be checking its characteristics. For that, the plate length A is 0.4, B is 0.3, H is 0.001. Now this plate we are taking it for our study, and on ansys we will be using static analysis. Now this is the basic of our project. This project is for that. To start our analysis, we will be doing convergence test. This is generally meshing the plate to find a optimal mesh size. Now our material is Kevlar. Then taking for the mesh size. Now first let's go with layup. Layup we would be using for convergence test to be 0, 90 alternate. 2 means alternate. That means there are 4 layers, 0, 90, 0, 90. You would understand it well. I will be showing it on ansys APDL. Now our conditions is 4 C's. That means all sides are clamped. Now the next step. Now you have to understand something, that for putting values on ansys APDL, you will be using a dimensional quantity, that is Q0, and this is a formula that we would be using it to find Q non-dimensional, and this will help us to plot graph. Capital Q, that is a non-dimensional quantity, and we will be using 50, 100, 150, 200 as the values. Now Q0 is found out accordingly from the formula itself. Now we have to plot graph. Before that we have to plot tables so that we can make graph. It would be capital Q versus W non-dimensional. So how to find W non-dimensional? That can be given by formula. This W is a dimensional quantity found out from ansys APDL analysis. Now okay, now just for the sake of information, Q versus W non-dimensional. Then we will be proceeding to mesh size. Okay, 4 cross 4, then 6 cross 6, then 8 cross 8, 10 cross 10, 12 cross 12. These are the mesh sizes for which we have to find values for corresponding capital Q. Like in this table, I have plotted for all of them. This is how we would be plotting for all conditions. Now it's for convergence test. Then we would be finding for A by H, A by B, boundary conditions, all of them. Now let's start on the ansys PDL. Sorry, preferences, structure. Now we have to define the element type. Before add, shell, 80281. Okay. Now time for importing properties. Now read from file. Actually, I have saved it so that we don't have to do it many times because there are a lot of variables we have to give input. So directly material import, and let's see if the data is imported or not. Density, yes. Now sections, shell. Now I was talking about layup. Here is the layup. Now this is first layer of Kevlar fiber. Now another layer is added. Is 0.001. Now this is 90. I was talking about 0, 90, right? This is how it means. Now this is 90 again. And so we have done for layup. Now it's time for modeling. Now we have to create area, rectangle through corners. Okay, our rectangle is made. Now it's time to mesh it. Mesh tools. Now we have to set. Now I was talking about mesh size, right? I'm doing here for 10 cross 10. Okay, now mapped condition, because now solution time. Analysis, I was talking about static. Here it is. Now no need for solution controls. Directly go for, okay, so wait, defining loads, apply, structure, displacement. I'm doing for clamped conditions, means all sides are clamped, so I'm picking up all sides and restricting their degree of freedom. Now I have to add some load over it, so go for apply. Now go for pressure over the area. Now as I was telling you about finding small q from capital Q from the formula that I have stated at the first. So now it is Q0 equal to 58.59 as we found out from the formula, and we have to input this value directly on the ansys APDL as input. This is a dimensional quantity since in ansys we are dealing with everything that is dimensional. Now time for solve. Solution done. Now it's time to see our results. Go for list results, null solution, degree of freedom, right? Now at the last we find the answer. This is the value of deflection we found, and we have to write it in our table as 10 cross 10 q equals 50. Our answer is 0.625. That's our answer. So now moving towards our APDL, let's see how to make how to plot stress. Right, let's see. Now similarly you have to go for q equal to 100, q equal to 150, q equal to 200. Complete the table, make a graph. This will be the convergence test for all clamp condition. Validation, this is the way you have to validate with somebody else's result. Now time to see stress. In result viewer, see stress and contours. You can see all the patterns, colorful patterns showing the maximum, minimum values. Now you can change it also to something different, pattern slightly varied. Now you can see others like Z component. Now everything is red, so it shows that there is no stress over it. XY is a shear stress over the plate. That's how it is. Now let's proceed for further study. Now after mesh size, that is convergence test, we have to do A by H, that is thickness ratio. A by H thickness ratio. After doing the thickness ratio, we have to find values of H and put it over that layer boundary, and the condition is 0, 90 symmetric. Means we are writing 0, 90, 90, 0. Then we'll be plotting graphs A by H versus non-dimensional deflection. Now this is how. Now thickness was 0.001, so we have to change accordingly. A by H is 10, so A is 0.4, so we're finding H equal to 0.04. We are substituting the values here. Now orientation, that would be symmetric, so 0, 90, 90, 0. It's done. Now okay, this is done, so we have to go for solutions. Now no need to add anything else, directly solve it. Close. Now we can see results again. We'll be having different results. So according to our table, under the effect of thickness ratio, we will be plotting q equal to 50. Under that, deflection. This is the deflection, maximum absolute values. Similarly, we have to do for a by b. A by b values are 1.1, 1.5, 2, 2.5. Now, orientation for this is 45 minus 45. Alternate. Now it is the same place where we were writing 0, 90. We would be writing 45 minus 45 on alternate. And now boundary condition. On the above, we would be also making a table for a by b versus deflection, and we have to do for each case. Q equal to 50, Q equal to 100, Q equal to 150, Q equal to 200. Similarly, for boundary conditions, we have to find for Q equal to 50, 100, 150, 200. Boundary condition, we have to again use 0, 90 alternate. Now time for a layup. Layup means we have to change the orientations, and we have to write for each case. Q equal to 50, layup 0, 90, 2, and all the layup conditions for Q equal to 50, then all layup conditions for Q equal to 100. Similarly, up to Q equal to 200, we have to find all of them. Then make tables followed by graph. Finally, again I would say you that we have to make tables for all of the conditions like thickness ratio, that is A by H, A by B, boundary condition. Along with, we have to vary Q, that is 50, 100, 150, 200, and for each of them we have to make tables like I showed you for mesh size. Now let me show you again how it was, how to remove loads and apply on areas. Okay, we're restricting the degree of freedom on lines or degree of freedom. Okay, then pressure over area selected. Okay, then put the value. Now solve it. And directly we can find our solutions now. At the last we would find the solution. Okay, now we have to plot tables. Now for a by h, we have to plot between a by h versus w non-dimensional, deflection non-dimensional. Similarly for a by b, here is a by b versus w non-dimensional. And we have to do this for q equal 50, 100, 150, 200 individually. And on boundary condition side, 4s means all simply supported, all c means all are clamped, all sides are clamped, c triple f means c clamped then all are free, sc means one simply supported, one clamped, one simply supported and another is clamped. Now coming to layup, we are making a table between layup versus w non-dimensional.